All right, so here we are, Module 6, limiting reagents. Okay, so again, we're going to go through the same steps we always go through. We're going to take it one step farther. So, fizz produced when an Alka-Seltzer tablet dissolved in water comes from the reaction of sodium bicarbonate. Sodium bicarbonate, which is this. So where is that? That's right here, okay? And citric acid, which is this. That's right here. Okay, suppose a tablet containing 1 gram of sodium bicarbonate, so 1 gram of this one. That's 1. I know it doesn't look like it. And 1 gram of citric acid. So 1.00 grams. Okay. Reacts to completion. So 3 sig figs. So we do all our things that we do at the beginning. So 3 sig figs. So that's our answer has 3 sig figs. So now, how many grams of CO2? So how many grams are produced? But we have this other part, and how many grams of excess reagent remain when the reaction is complete? Okay, let me talk about that one for just a second. So, we have a reaction. I'm trying to think the best way to show you this. So we have a reaction. So the first thing to do is, 1, figure out how much you make. So with that, you're going to determine limiting reagent. Okay, and excess. So in other words, so A plus B goes to C. You take A to C, take B to C. Smaller number is how much you make. One that makes smaller number is the limiting reagent. It's the one that runs out, okay? So at the end of the reaction, there's none of that left. It runs out. It's totally 0. But what does that mean? Other is excess. So let's say, for all practical purposes, that in this particular reaction, this one is our limiting reagent, this one is our excess reagent. Okay? So we figured that out because we figured out numbers, okay? And I'm just telling you what the B made a smaller number, so of C. So B is our limiting reagent. So that means at the end of the day, B is 0. That means we have A left. So then our next step is figure out how much of excess reagent you needed to make that much stuff, to make that much product. So, okay, so if that one's limiting, then what we do is we go from there to there. How much did we need to produce as much C as we made from B? So this was limiting. So then we figure out how much C we make, and then we figure out how much A we needed. Then it's just how much started with minus how much needed. How much used or needed. that equals what's left. Okay? But the path is weird because you start out, and I agree with this, you take both of them here, compare the numbers, pick the smaller one. Again, we said that this one was limiting, so then, but then you take, and you could go either direction. You could go from here to here, you could go from here to here. They will give you the same number. It does not matter. Okay? Figure out how much you need, how much you will use, and then subtract. Okay? So let's do that. All right? We're going to do that in this problem. We're going to do that right here. Okay? 3 sig figs. We're going to start. 1 gram NaHCO3. Okay? 3 sig figs. I'm not going to worry about 1.00. 84.01 grams NaHCO3, 1 mole NaHCO3. And if it didn't say CO2, you could take it to anything. It doesn't matter. Some of our problems don't say what they go to. They just say which one's limiting and which one's how much is left. Okay, take it to anything. Just take it to some product. It does not matter which one you take it to. Okay, so for 3 moles of NaHCO3, we have 3 moles of CO2. And in 1 mole of CO2, we have 44.01 grams CO2. So that one makes 0.542 grams of CO2. Okay? So that's one. Now let's take the other one. 1 gram of citric acid. Okay? And so citric acid is, I think it's 192.1. I don't have my glasses on. I'm old. 1 mole of citric acid. Sorry about that. So for every 1 mole of citric acid, now we go back and we're going to be red, and we're just going to copy all this red stuff. 3 moles of CO2. For every 1 mole of CO2, 44.01 grams of CO2. So that is 0.687 grams of CO2. Okay, smaller number, that's how much CO2 we're going to make. 0.542, 3 sig figs, okay? So that's the first part of our problem. Whoops, how many grams of CO2 are produced? Now to figure out how much excess is made. So that means this one's limiting. This one is excess. So how much of that did we need? Well, we got to figure that out. How much citric acid did we actually use? Okay. So we're going to go then backwards from here to here. Okay, so our path was we went from here to here, and now we're going to go to here. Okay. Like I said, we could go many paths. It doesn't really matter. So we're going to start with 0.542 grams of CO2. We're going to kind of do this upside down. 44.01 grams of CO2. 1 mole of CO2 times, and then we're going to look at our reaction. 3 moles of CO2. And we'll use this blue one. 1 mole of citric acid times, in 1 mole of citric acid, we have 192.1 grams of citric acid. So that tells us we need 0.762 grams of citric acid. Okay. 1.00 minus 0.762. Okay, and that's 0.24. Sig fig rules, you're adding. Okay, so our answer only is going to have 2 sig figs. 0.24 grams citric acid remain. Okay. So we figured out how much we used. This number should always be less than what you started with. If it's not, you picked the wrong limiting reagent. Okay. This is about as hard as the problem gets, but it's hard. There's a lot going on here. So hopefully, this little explanation kind of makes sense. You can kind of figure out what it is we're having to do, what our steps are, and then you can go through the process and do the steps, and you see that we're going up, over, and then down, over. Okay. There you go. Good luck.